Good morning, my name is Adham Hani, and today we're going to solve some questions about trigonometry. Let's start. So the first thing is the Pythagorean theorem. We use it to find the missing side in a right triangle. If we're given a hypotenuse and a leg, we use this formula to find the missing leg. And if you're given two legs, we use this formula to find the hypotenuse. So here we're given a hypotenuse and a leg. The hypotenuse here is 5 and the leg is 3. So we'll use this formula and then we'll substitute. It will be square root 5 power 2 minus 3 power 2, which will be equals to 4. Trigonometric ratios. So the side opposite to the theta is called the opposite, and the side opposite to the right angle is called the hypotenuse, and the other side is called the adjacent. Sine equals opposite over hypotenuse, cosine equals adjacent over hypotenuse, and tan equals opposite over adjacent. Cosecant is the reciprocal of sine, and secant is the reciprocal of cosine, which is hypotenuse over adjacent, and cotan is the reciprocal of tan, which is adjacent over opposite. So here, let's solve. We need to identify each side first. So here's the side opposite to the theta, which is 3, and the side opposite to the right angle, which is the hypotenuse, is 5 here, and the other side is 4. So sine equals opposite over hypotenuse, which will be in this case 3 over 5, and cosine will be 4 over 5. Tan will be equals to 3 over 4, and these are the reciprocals of each of these. Using ratios to find sides and angles. Here we have a missing side, and this missing side is the opposite of the given angle. And we know we have a given side, which is the hypotenuse. So we have an opposite and the hypotenuse, so we'll use sine because it's opposite over hypotenuse. We'll substitute first sine theta here, which is 29, equals x over 8, opposite over hypotenuse, and then we get this 8 here with multiplication, so it will be 8 sine 29 equals x, so x will be 3.8. Let's continue. Here we have a missing angle, and this missing angle we're given its opposite and its adjacent. Its opposite is 9, adjacent is 10, so we'll use 10 because it's opposite over adjacent, 9 over 10, and we'll get this 10 there with shift 10 or 10 to the power of -1, and then it will be 42. Law of sines. The law of sines, we use it if we're given a side and the angle in front of it, or and side and the angle in front of it, because it states that sine B over B equals sine C over C equals sine A over A. Let's continue and solve to understand. Here we need to find this angle, and we're given a side and its opposite angle. So sine 40 over 6 equals sine B, which is the missing angle, over 8, which is its opposite side. And then we cross multiply this multiplied by this multiplied by this. It will be 8 multiplied sine 40 over 6. And then we multiply them, and then we use shift sine of the answer that we have from here. The answer will be 59. Law of cosines. Law of cosines, we use it if we have 3 sides or 2 sides and an angle and the angle between them. So if we have those or those or those, so we'll use square root. If we need to get this side, we'll use square root b power 2 plus a power 2 minus 2ba cosine c. Let's continue. Let's solve. So here we need to find this missing side, and we have 2 sides and the angle between them. So we'll do square root this side power 2 plus this side power 2 minus 2 multiply this side cosine the angle here, the angle opposite to the missing side. So the answer will be 8.5. And now we'll find trigonometric ratios if we're given a point. If you're given a point, we'll use to find the trigonometric ratios. We need to find something called the r. The r equals to square root x power 2 plus y power 2. The r has the same formula like the hypotenuse. Sine equals y over r, cosine equals x over r, and tan equals y over x. Cosecant equals r over y, secant equals r over x, and cotan equals x over y. Let's continue. So here we're given this point, which is x and y. The 4 here is x and the 3 here is y. We'll find r first, so we'll use this formula, which will be equals to 5, and then we know that sine equals y over r 3 over r, which is 5. Cosine equals x over r, 4 over 5. Tan equals 3 over 4, which is y over x. And these are their reciprocals. Area of a triangle. To find the area of a triangle that we're not given a height of, we use this formula. We need to have two sides and the angle between them, like this example here. So the formula is 1 over 2 or half, multiply a side, multiply the other side, multiply the angle between, multiply sine the angle between them. So it will be, according to this, 0.5, which is half, multiply this side, 11, multiply the other side, 12, multiply sine the angle between them, which is 30. This will be equals to 33, so the area is 33. Let's continue. Trigonometric identities. We have three types of identities: reciprocal, Pythagorean, and quotient. The reciprocal says that sine equals 1 over cosecant, cosine equals 1 over secant, and tan equals 1 over cotan, cosecant equals 1 over sine, secant equals 1 over cosine, and cotan equals 1 over tan. The Pythagorean identities: sine power 2 plus cosine power 2 equals 1, tan power 2 plus 1 equals secant power 2, and cotan power 2 plus 1 equals cosecant power 2. The quotient identities: tan theta equals sine theta over cosine theta, and cotan equals cosine over sine. Let's continue and solve. So here we're given sine x, which is 3 over 5, and we need to find cosine. So we think about the identity that have them both. It will be the Pythagorean identities that states that sine power 2 plus cosine power 2 equals 1. So here we'll substitute the sine with the 3 over 5. The 3 over 5 power 2 plus cosine power 2 equals 1. And then we get this there by the subtraction. We subtract, and then we put a square root to find the answer of cosine. Here we're going to use identities to simplify this expression. So we need to turn everything to sines and cosines to make it easier. So here we know that tan equals sine over cosine. So sine multiply sine over cosine, it will be cosine plus sine power 2 over cosine. And then we add. First we need to make it the same denominator. So multiply the denominator of cosine by cosine and the numerator by cosine as well. So cosine power 2 over cosine plus sine power 2 over cosine, which would be like this. We know according to the identities that this is equals to 1. So 1 over cosine will be equals to secant, which is the answer. Let's continue. So we're going to verify this identity. We're going to verify that this side is equal to this side. So we change in this side to make it just like this side. So according to the identities, we know that this numerator is equals to sine power 2. So it will be sine power 2 over sine. We'll cross this sign with this power 2, which would be sine. Sine equals to sine. Let's continue. Coterminal angle. To find the coterminal angle, we need to add 360 until we have something positive and subtract until we have something negative. So we need to find this the coterminal angle of 230 degrees. 203 plus 360 would be equals to 563, and which is the positive coterminal angle. And 203 minus 360 would be equals to negative 157. Let's continue. Radians. If we're given a radian and want to turn it into a degree, we need to use this formula. I mean. And if we're given a degree and we want to turn it into a radian, we're going to use this formula. If we're given a degree, we're going to multiply it with pi over 180. If we're given a radian, we're going to multiply it with 180 over pi. Here we're given a radian, and we're going to multiply it with 180 over pi to get the degree, which will be 120. Here we're given the degree, and we're going to multiply it with pi over 180, and this will be the answer, which is 2 pi over 3. Reference angles. To get the reference angle of any angle, we need to know in which quadrant it is. So if it's in the first quadrant between 0 and 90, we use this formula, which states that the reference angle of any angle is equals to this angle. And if it's between 90 and 180, we'll use this formula, which states that the reference angle equals 180 minus the given angle. If we're given an angle between 180 and 270, we'll use this formula, which states that the angle, the reference angles equals the angle minus 180, and if it's between 270 and 360, we'll use this formula, which states that the reference angle equals to 360 minus the given angle. Here, we're given 125. We need to know in which quadrant it is first. So it's between 90 and 180, the second quadrant. So we're going to use this formula, which is 180 minus the angle that we're given. 180 minus 125 will be 55. Thank you.